Okay, it's time to talk about present value calculations. And in this section, we're just going to go through some finance sort of related information. Present value calculations fit into long-term debt because we end up producing usually amortization schedules that show how present value works. Let's give it a go. So if we look at this first of all and say, okay, what's the theory behind this? Well, what we are doing is we're recognizing that a dollar that you might have today will be worth more than a dollar in the future because we can earn some sort of investment on that income. In other words, if we own a dollar now, we'll be able to invest that dollar and it'll be worth more than that dollar at the end of some period in time. So let's try an example. So if we had $90.90 on January 1st of 2021, and if we could earn 10% on that $90.90, if we invested it, then we would expect to have $100 at the end of 1 year. And the calculation, just to show you, it's $90.90 times 10%. That's equal to another $9.09. Add that to the original $90.90, and you have $99.99 rounded $100. So based on that calculation and using 10% as the parameter and 1 year as the term, that's how much we expect we would earn. Now here's an example where if we borrowed the money, so let's say we borrowed from someone $90.90 on January 1, 2021, and the lender wanted to earn 10% on their money, then we would owe the lender $99.99 rounded to 100 at the end of 1 year. That in itself is the crux of this, the premise of present value calculations, that depending on the interest rate, the length of time, whatever funds you have now in the future will be worth more, and whatever funds you have in the future will be worth something less today. So let's have a look at some present value tables and just calculate the same number. So if we know that the present value, or if we know we have $100 and we want to get back $100 2 years from now, and we're assuming we want to make 5% interest on whatever it is, we can use the present value of a dollar to determine that amount. So it's 2 years at 5%. So let me just show you a calculation here. Here's a present value table. And if we know 2 years and 5%, that number is 0.907, then that means that on $1,000, if I had to pay back $1,000 at the end of 2 years, I would just take the 1,000 times 0.907, or $907. I would take that $907 and say, that's how much today I would get, and then I would pay back $1,000 2 years from now, assuming an interest rate of 5%. So a little different, but yeah, it works. We can also look at this from the point of view of an annuity. An annuity is just a series of cash flows. It's over a period of time getting the same cash flow, and we can figure out what the present value of all those cash flows is at the same time. So let's say we wanted to receive $1,000 at the end of each year for 5 years, and we wanted to earn 8% on our initial investment. Then we could use a different table, a present value of an annuity table, to do that. So this is 5 years and earning 8%. So if we go back to the next schedule, which is this one right here, so we had 5 years and we wanted to earn 8%. So that's this one right here, 3.993. What that means is that we would take $1,000 being the annuity amount that we would like to get every year at the end of the year for 5 years and at 8%. So we would lend $3,993 today, and every year for the next 5 years, we would expect to get $1,000 from whoever we had loaned that to. So if you do the calculations, it's pretty neat. In fact, we're gonna do that. We're actually gonna prove it. So um, if you create an amortization table and you see we've got a beginning balance here of 3,993 is what we figured out. And if we make a payment 1 year later, so $1,000 with 8% interest on that $3,993, we'd pay that in interest and we'd pay principal of $680.56, bringing the loan balance down to $33,1244. That's at the end of the year. And you can see if we keep making these $1,000 payments and paying 8% interest on whatever the ending balance is, that gradually we pay off all of the interest and the principal. We end up at zero after making that last $1,000 payment on 5 years after the initial loan. Isn't that kind of neat? That's how present value tables work, and they're really handy. You can use your calculator as well to get the same sort of ideas. It'll do it all sorts of different ways, tell you different ways to get the different payments, different interest rates, that sort of thing. I think if you can just get your head around that these are tables that are designed to help you figure out what numbers you should have for payments and interest and that sort of thing, that's great. It all applies back to those long-term debt amortization schedules that we talked about. All right, hope you enjoyed this section.